don't know who you are. I don't know what you want. If you're looking for ransom, I can tell you I don't have any money. But what I do have is a very particular charge. Charge I've acquired over a lot of shells. Charge that makes me a nightmare for ions like you. If you give me back my electrons now, that'll be the end of it. I will not look for you, I will not pursue you. But if you don't, I will look for you, I will find you, and I will bond to you.
Ionic bonds, taken, not shared.
Sorry about that, now we've got that sorted, we're on to ionic bonding. It's the first of the 3 types of bonding that we do at this level. Now, ionic bonding you actually did at GCSE. When things bond, they want to get 8 electrons in their outer shell. So some give electrons, some receive electrons, so that they've got a complete outer shell, and we know that from GCSE. So if we take the example of table salt, it's a nice, easy example to sort of talk through at the start. So that's NaCl, 1 lot of that to 1 lot of that. Now sodium, in its outer shell, if you look in the periodic table, it's got its inner shells, we don't have to draw them, but in its outer shell it's just got the 1 electron, like that. And chlorine, as it stands, has got, if you look in the periodic table, it's got its inner shell, and then it's got 7 in its outer shell. So neither of these are stable, so that's why they bond together to both get 8. Now when they do that, you're right.
Oh, shut your electrons.
Oh, that must have been really difficult to get.
Yeah. Oh, I don't need the drips anyway, it's fine.
Okay. Yeah. So when they bond, that's wanting 8, this is wanting 8. Now this could lose 7, but that would be really inconvenient, so it doesn't do that.
So instead, the sodium loses 1, and then its next shell it has a full shell. But you don't draw that in your box, you just draw an empty box, essentially.
Yeah, you can draw an empty circle, or no circle at all.
Yeah, and for this one you do the same thing. Do a box here, but you draw the sodium one, the sodium's electron, but you have to show it's different, to do it as a ball instead of a cross or something.
And then to top it off, this has lost 1 electron. Electrons are negatively charged. It was neutral as a thing.
Yeah.
If it's lost 1 overall now, it's going to be positively charged. A lack of 1 negative.
And equally this will go up 1, so it becomes negative.
And these boxes, that's how we display ionic bonds if they ask you to draw it. They do
Yeah.
not bond together. That's covalent bonding when you actually draw them as things.
Yeah, they actually form a giant ionic lattice,
Yes.
where there's lots of them sort of almost touching each other. You have to draw it a bit like that, but yeah.
They're going to be somewhat structured, and that's why you see table salt was a nice solid little crystal bit, the little balls of crystal.
Yeah.
And that's the first part of ionic bonding. So let's go through a slightly trickier example.
Okay, so they don't just give you salts. But the few things you have to remember when doing ionic bonds, when they're in ion form, they are ions, but when they're on their own, they're atoms, and in other compounds, they're compounds. And atoms and compounds haven't got charge.
Yes.
And that's the thing you to remember.
Na2O, that is a compound that doesn't have an overall charge.
Yeah.
Because they balance out, like the NaCl, that didn't have an overall charge, because the Na became a positive, the Cl became a negative.
But when they come together, charges equal, so it becomes no charge. That's what you need to happen to form one.
So we go back to this example, we now know what sodium looks like. They've each got 1 electron, and there's 2 of them. So they've each got 1 electron in their outer shell, with this.
And oxygen, sitting here, has 6 in its outer shell.
Yep. It's got 2 like that, and then it will have 1 and then 1 like that. So it's got space for 2 things to bond to it.
Yeah.
But it's going to form an ion, and it's going to form an ion because this is on the left-hand side of the periodic, being a solid, and this one is on the other side, being the gaseous.
Yeah.
That's how you know.
Yeah, you sort of think about it, metals often are the ones that give the electrons, anything that forms a positive ion, which you end up needing to learn, really.
Yeah, we'll go through that in just a second.
Yeah.
About that. So the same thing's going to happen, but now we've got 2 Nas, which is why it's slightly trickier. The electron's going to be lost from there to make it stable.
And this will happen to both.
So then they're both stable with this complete outer shell, like this. So they're both plus. So you have to draw it twice.
And then the only thing that is different happens here, because as it gains 2 electrons, it becomes 2 minus.
And that's why 1 lot of that balances 2 lots of that overall to be 0. And you've got to draw it just like that. The 2 different things go into 2 different areas.
But you can know what the bonds will be, even if you don't actually know the molecular formula, by just looking at the periodic table.
Yes, so they might try and give you awkward things that you
Yeah.
don't often come up in the book.
So for example, things that you have no idea what charge they are, like manganese or something. But you can work out what they should be by using ones you do know. And the ones you do know are most of them. So group 1 and 2 we have to know, and group nearly all of them apart from 6 is a bit dodgy sometimes.
Yeah. So we've got 8.
It is a bit unclear, so this is 8, so it's 7, 6, 5, 4, 3, 2. We've gone wrong then. 3, 2, and 1.
So that's your periodic table.
Those are groups.
These are stable, they've got a complete outer shell, so they're ionic charge, they won't bond, they've got 0. They're not going to do anything.
Yeah.
Likewise, 7 needs to gain 1, so it could be a +7, but it won't be.
It won't be that, so instead it'll just be a -1.
Yep. Likewise, 6 will be -2, and 5 will be -3. That's sort of the general rule, these are the things you'd follow.
Yeah.
Some of them, as Triv said, are awkward, but we get onto that a bit more in A2, what some of them are a little bit awkward. But for AS,
Yeah.
that's a general
You can
formula.
sort of assume that, like, oxygen's group 6, it will always be 2-. So you can it's often oxygen they use, you put in a thing, and then it says what is the ionic charge on this thing, and you can work it out.
Yep. Likewise, on the other side, this could gain 7, but it's not going to do that.
No,
It's
it's
just
gonna
going to
lose
lose 1.
So that becomes 1+. Next one becomes 2+,
And this group over here,
3+. Actually, group 4 was awkward, not 6, and
yeah, 4 just ignore for now. It sort of bonds to itself, carbon bond to itself, then we get our organic chemistry, which is the second unit of A2 chemistry, will go into carbon.
and how that works.
Transition elements, ignore, that's A2, we do all of those bondings. What it might do is tell you a charge. It might say iron is 3+.
Or you might have to essentially work it out.
Yeah, by giving you other things, that's the only thing. You
Yeah.
don't have to memorise what these make, because they can
No.
actually make more than one, is what I'm saying.
But it could say, like, Fe2O3, what is the charge on one ion?
So how would you go
Iron.
about that, Triv?
Well, you know the charge on oxygen,
Yeah, because oxygen is here.
it's 2-. So if oxygen by itself is 2-, and there's 3 of them, so that must be 6- in total. And that must balance out, but there's 2 of them, so each one must be 2, 3+.
3+. That will balance out, and that's the sort of thing you have to get. So
Yeah.
you don't need to memorise this, is all I'm saying.
Yeah. You don't really need to memorise anything, you can just look at the periodic table and sort of logic it if you find that easy.
Yeah. Same thing at the top here. Helium has a complete outer shell, so we just ignore that.
Yeah, that's essentially a noble gas, it is a noble gas, and hydrogen is in group 1.
So
it's
it
just not a
becomes a +1, like
Yeah.
that. So I've mentioned that. So these you have to remember. Group 4, just ignore for now.
Yeah,
And that's ionic bonding, really, in a nutshell, all of the things for
it
now.
is. We'll go on to that next structure in another video, but
Yeah. For now, we're going to go on to covalent bonding.
yeah, I really fancy a martini now.
How do you take it?
Oh, shaken, not stirred.
Ah,